So we have been looking at loops. So far we have seen two types of loops. Loops in which we got a container and we were looping through the elements of that container, which is very common. Also, we have seen the range function to loop through certain numbers. So for example, 1 to 100, or printing hello world 100 times. We can use the range function. We are going to continue a couple more different variants of loops because it's a very important topic. So the first kind of variation I would like to show you is giving a step inside the range function. Default, the step is 1. Now I'm going to give it 2. Now what is expected is the jump from 0 to 10 will happen in 2. So all the even numbers will get printed now. So let's see that. 0, 2, 4, 6, 8. So this is the step, how much we are jumping. Now if I put it 3 and restart, we'll be getting all the multiples of 3, 3, 6, 9. So this is the start, this is the end, and this is the step. So range function, pretty useful in loops, and this is a syntax for it. The next variant I would like to show you is this, very similar to the first one we have seen. In this case, I have a function here. Line number 12 and 13, we have seen functions. That function has no input. It is not taking any inputs here. There is no input to the function, but it has an output. What is that output? This is the output of the function. It is returning a list, which is the same list as here. We have commented it out. Let me comment this out as well. Control / that is the easy way to comment something in Visual Studio Code. So this is the output of the function and it has no input. Otherwise it's a standard function. The name is pretty long. I'm very fond of long names like this. It looks like a comment. And 15 and 16, those are the line we would like to focus. And in this case, if you look, instead of the container itself, I have given the function right here. If I restart everything, you can see you got apple, orange, mango, and grapes. Another variant is just directly giving the list like this. Let me comment this out. Restart, we are expecting the same output. Apple, orange, mango, and grapes. So what the summary is that after the in, we need a list or something to iterate on. There are a couple of different options there. There are a couple of different functions. But for now, all we need is these are the variants which we need. So we will be keep seeing for loop. And next and final type of loop I would like to discuss is while loop. Normally, all programming language has two types of loops. One is for loop and while loop. They are more or less similar. In fact, I would consider it's just another syntactical sugar, which is nothing but two different ways to do the same thing without much of a difference. Over a period of time, you may prefer one or the other. For some reason, I always prefer to use for loop, and occasionally I use while as well, but normally I like for loops better than whiles. But it's your personal preference. But in almost all the programming languages I know, there is for loop and while loop and variants of similar things. So again, getting back to Visual Studio Code and looking at the while loop, line number 23, every other line is commented. Line number 23, nothing but a variable right here. And that variable is having the value 0, doesn't have any value. And there is this while statement. This is a while keyword. And open bracket, close bracket, then the variable. And this is a condition. Remember, this is a conditional operator. Count less than 10. That is how it is read. While count less than 10, do this. That's how it is read. As long as the count is less than 10, this will keep executing this loop. So one of the things you need to remember in a while loop is you need to increment the counter. So this is a thing we need to focus our attention to right now. Line number 26. Line number 25 is pretty straightforward. Line number 26 is very interesting. This is not something we have seen, and this is a very clear statement which proves that equal to is not what we think it is. It is assignment. So let's try to understand line number 26, very important. Count equal to count plus 1. It's a very common operation in almost every single programming. Count equal to count plus 1. Count is a bag. That bag contains something right now. Say that bag contains 100. Now what we are doing is, whatever that bag contains, we are adding 1 to it and putting it back to the bag. That's what line number 26 is doing. Very important. Whatever the bag contains. So the execution comes from right to left. So from here to here, right to left. So first this is executed. So what is the current value of count? Taking that and then adding 1 to it and putting it back into the same variable. You will get used to it, and it is very important to understand that. Not very straightforward, especially if you're coming from a math background. This statement is not very straightforward. Let's see that in the debugging. What I'm going to do is I'm going to press F10. No surprise, the count value is at the moment it's 0. Let me close all these things and put a watch on the count. It's already here, but I will put anyway. So count equal to 0 right now, and I'm going to print it. No surprise, you got it right here. Now what is count plus 1? Let's see, count plus 1. No surprise, count plus 1 is 1 because count is 0. Now what is the value of count after the execution of line number 26? That is going to be 1. Why? Because count plus 1 is 1. So remember, this is the calculation it is doing first. Then it is doing this operation. So right to left, right is first. So this is the operation it is doing first. So there are two operations. One is addition plus and assignment. Addition first, then assignment. That's how it works. Let's see that. So now the count has become 1, like we discussed. And now the next thing we are going to do is we are going to check, just like we did before, if count is less than 10. So count is indeed less than 10. So I have added that to the watch. Because that is true, we came here into the loop, printing 25 and 26, executing, again repeating. Now count plus 1 is 3 and count is 2 because we added 1 just like we discussed before, and we are continuing. So as you can see, the statement is true. Which is statement? This particular comparison, count less than 10, which is true. That's why the while loop is getting executed. Keep going. Right now count is 6, 7, 8, 9. So count less than 10. That is true because count is 9. Now the count has become 10 after this particular execution. As you can see here, count less than 10 is false. So this condition is false. Now, because of that, this will never execute the loop. So the loop is exited and the program is ended. As you can see here, it's printing 1, 2, 3, 4, 5, 6, 7, 8, 9, just like before. So while loop, very similar to for loop, slightly different syntax. Again, the rules of bracket is very similar to if condition we discussed, just that it keep executing this while the condition is true. If execute only once, while execute until this condition is true. So one of the things I would like to do is just remove line number 26 and see what happens. So I'm going to remove, not for long, and see what happens. So if you are doing this in your system, be a little careful. This is gonna hog my CPU. I have a pretty powerful system here, so I'm not much bothered. I don't think this program is gonna kill my laptop, but this is going to take my 100% CPU. This is called infinite loop. The reason why it is going to be infinite loop is I'm not changing the count. I have removed that statement. Let me control Z. Let me comment it out rather than remove. So I'm putting hash here. So now the count is always going to be remain 0. And this condition is always going to be true and this print will happen all the time and the program will never end. But fortunately, we are inside the debugger and we have a very friendly operating system. So we will kill the program. We'll interrupt the program and we'll kill it. Otherwise, it'll take the entire CPU. So let's see that. Again, if you're working on a very small config, please make sure that your CPU is okay with it and you are not hanging your entire system. So start debugging. As you can see, this is executing. Not sure if you can see the blinking of the 0 here. So it is keep printing. So let's see how much is the CPU usage. I'm going to Task Manager. As we can see, Visual Studio Code is taking 11% CPU. So 11% CPU Visual Studio Code is taking to do all those printing in infinite loop. So the printing is happening inside Visual Studio Code. Python is also there. So this is the Python, which is not on the top of the CPU, but it is a Visual Studio Code. All the energy is spent in printing right here. My laptop fan started working. I don't know if you can hear the sound, but I can hear the sound of the fan laptop because CPU started working and it is heating up because of this program running. So if I go to performance, I can see my CPU usage is pretty high because of this program running, as well as screen is recording. A lot of things are happening. So CPU is pretty high. Although Visual Studio Code is using only 10%, rest of the system has to work to do the printing and stuff like that, rest of the things. That's why my CPU is pretty high. So I stopped the program. So I put a breakpoint right here and you can see the CPU is dropping drastically. The CPU has dropped drastically because that was an infinite loop program which I stopped by putting a breakpoint right here. So if you want, what I can do is I can put this always on top. There was some setting in Task Manager to show it always on top. They change it all the time. I'm not very familiar with Windows 11. Yeah, it is right here. So now this will be always on top. Let's see the performance tab. I'll just reduce the size of it a little bit so that we can see the code as well, the execution of the code. Yeah, so the CPU is around 9% right now. Everything is calm and quiet. Now what I'm going to do is I'm going to let this go. So I have a breakpoint here. I'm going to remove the breakpoint. I remove the breakpoint and letting it go. So as you can see, the CPU has spiked then and there itself. I'm doing okay with the recording, hopefully. Otherwise you won't be hearing this. So the logical processors are 8, but it's taking almost everything to do that printing stuff which we are talking. Now I'm going to pause the execution, or you can put a breakpoint, either of that. Now the CPU has reduced. So this is the example of an infinite loop using while. When the counter is not incremented, this condition is always true and it gets executed infinitely until someone terminates it. In this case, it's the operating system itself. So operating system has a good control on programs like this. So this is a rogue program which is hogging the CPU and disturbing the entire system. So operating system has good control on it. Otherwise, we won't be able to stop it. Even debugger uses the operating system's help to stop it and clean that program from hogging the CPU. So that is all about loops we are going to see right now. We will keep seeing loops more in the coming sections. And we have seen for loop and while loop and a couple of different variants and features of it.